All right, we have a couple of questions today from Wilcox, and I'm going to do a video for each one, quite honestly, because it's going to take a little bit more than 5 minutes for each of these. But let's start with question one. So question one here is asking, what are the solutions of sine of x minus pi plus 2 equals 1 within 0 to 2 pi, 0 inclusive? What does this part mean? Let's start there. What does this mean? What are they talking about 0 inclusive 2 pi? They're saying that for these particular, we want to stay within this domain of radians. So we have to stay within this domain of, and if we're looking at the unit circle, this is what we're usually using for trigonometry. We're starting at 0 and we're going around the unit circle to 2 pi. So we can include all answers up to 2 pi. Well, up to, but not including 2 pi technically. Anything over that is beyond the domain. So we don't want, say, 7 pi over 2 or anything like that. We don't want anything crazy like that. We want to stick within 0 to 2 pi only for x. X, by the way, is confusing. We were usually thinking in terms of x like this graph down here. Let's think of this instead in terms of radians. I'm going to keep it like this, or theta is a better way to think of it. So we'll think of that in terms of theta instead of x in our mind's eye, but here on paper we'll keep it to x just to stick with the problem for a moment. I did go on and graph it. So this is what this would look like as a function if we wrote it a little bit differently. What I want to do in order to write it a little bit differently is make it equal to 0 instead of equal to 1. So if I subtract from both sides of this guy, what I'm going to get is sine of x minus pi plus 2. Oh, pardon me. We subtracted 1 from both sides. I just said that. So now it's plus 1 equals 0. Equals 0. This can be our function for today. This can be the function, so that if I graph the function, that is, forgetting about the 0 part for a moment, if I graph this as the function, I get this graph over here. So let's think about how that corresponds with our unit circle. That means that if we have to stay within 0 to 2 pi for our unit circle over here, then what we want to do is only consider those. I'm still getting used to the graphics tablet here. Then we want to stay within 0 for x proper here, 0 to, what is 2 pi? Pi is 3.14-ish. So 2 pi will be twice that much, or 6.28-ish. So right about in here. All right. So between here and here is the only part that we care about. And we're asking when that's equal to 0. When is that equal to 0? If we want to solve for x, we're going to do what we always did throughout Algebra 2 and Pre-Calc. We want to solve for x. We have to think about what it is when it's equal to 0. That's the question we're asking. And there's only one time it's ever equal to 0. The function is equal to 0 here. And we can guess what that is, given the periods and whatnot. But instead of guess, let's solve this algebraically so we can get a really concrete sense of what's happening, what it is we're seeing. So let's make it equal. Let's keep it equal to 0 for a moment, and let's actually solve for x algebraically. So if I subtract 1 from both sides, I'm going to get sine of x minus pi. All right, I'm subtracting 1, so that's going to be 0 on that side. There's not going to be a plus 1 on that side. This is not going to be 0 anymore. That's going to be -1. Getting distracted by my own messy handwriting on this platform. There we go. And now I seem stuck, right? Well, let's think about arcsin. I know they want us to use arcsin because they're actually asking for arcsin in the next question. If we use arcsin, or the inverse sine function, what we're going to do is when we use it to both sides, we're going to get rid of the sign on the left-hand side, minus pi. So that's pretty. That goes away. It's like an inverse function. It is an inverse function. It just makes that first function of sine go away. And then we're going to be asking, I'm going to write it a little bit differently. This is my preferred handwriting. Inverse sine of -1. So what we're asking with inverse sine is, what is the value of theta? So if this is sine theta, what is theta when sine of theta is equal to -1? And that only happens one time for sine. It only happens down here. If you remember that sine of theta corresponds to the y coordinate too, you'll see that that means that the x coordinate or cosine value would be 0, and sine theta would be -1. So it only happens one time on the unit circle for sine of theta, right there at, what is this? This is 0, so this is pi over 2. Let me keep this green. This is pi over 2 radians. This is pi radians, or 2 pi over 2, which is pi radians, and then 3 pi over 2 radians gives us -1. So we can rewrite this as x minus pi is equal to, inverse pi of -1 we saw is 3 pi over 2. Now we're going to see a little problem with this in a second, but let's stick with it for a moment. And actually, one way we can actually avoid the problem, let's think about how we can avoid the problem, because we're going to need to do this in the second video anyway. When we're thinking in terms of arcsin, we actually have to think about it as an ugly little graph that I've just made, but bear with me for a moment. And I will try and do better. All right, if we're thinking in terms of arcsin, I'm just going to draw another unit circle down here to explain arcsin for a moment. Then actually we are restricted in our domain for arcsin between -pi over 2 and pi over 2 inclusive. And I'll be sure to make another video. There are lots of explanations why we restrict the domain to that. It's very important and very interesting. There's a very beautiful visual way of understanding it. But for now, let's just keep it here. We know that for arcsin, or let's say inverse sine, since I wrote it that way the first time. For inverse sine, can't get my, there we go. Inverse sine, the domain, of theta, the domain is going to be -pi over 2 to pi over 2 inclusive. We restrict it to this for a reason. So if we're restricting it to that, let's think about what that means. That means that we actually can't go over pi over 2 here. So going all the way around to 3 pi over 2 is actually a no-go, because if we're going over pi over 2 that direction. So instead, let's get to the same value -1 by going in this direction. Well, if this is pi over 2 going that way, this is going to be -pi over 2 going this way. And we'll see that actually works out. If we kept using 3 pi over 2, we'd actually be going over our domain restriction here, 0 to 2 pi. So what we really want is, we're saying this is equal to now 3 pi over 2. Sorry, not 3 pi over 2, -pi over 2. There we go. Now if we solve for x, this is the easy part. If we solve for x by adding pi to both sides, then that -pi over 2 becomes a positive pi over 2. And this is the solution to that first question. X is equal to pi over 2, and there's only one value where we get that. So this over here is going to be pi over 2. Pi over 2, and we can say that that's pi over 2, 0 in terms of a coordinate point. Okay, fantastic. Coordinate point. A point is the coordinates of the point. Okay, so is there anything else to take away from this? Well, let's bear in mind how the restrictions on the domain of arcsin or inverse of sine, and what they're asking for in terms of 0 to 2 pi for regular sine when we go into the next question, which I will make in the following video. In the meantime, you can test this, and I do recommend you test this by plugging in pi over 2 and seeing how, whether you plug it in here or you plug it into the original expression in the question up here, you will find that pi over 2 is indeed the solution that you're looking for. So hope this was helpful, and do reach out if there's anything in this answer that you would like further details on.